these are test tips for Unit 4. Go ahead and take your paper and you can fold it in half. I'm going to use both sides. I want to let you know that the test itself is going to have a, so be prepared for that. And then secondly, that the answers on your test all come out nice and clean, nice integers. So if you get really squirrely decimals and that kind of thing, you're doing something wrong on the test. So let's go ahead and look at our test tips. I tried to pick out some problems that would really help you, so I hope it's of benefit to you. So here's the first question. So it says solve this by graphing. Now in order to solve by graphing, we want to get our lines graphed and find the intersection point. That's where the solution is, where the two lines intersect. So in order to do that, we want to get both lines into slope-intercept form, which is y equals mx plus b. Okay, so the first one, we're in good shape, but the second one, we need to change to slope-intercept form. So I'm going to do that, and I want to tell you there's a little typo here. This should say -4, not +4, so let's put -4 right there. Now I'm going to add 3x, and we get -2y is equal to +3x minus 4. Now I'm going to divide by -2, and I get y equals -3/2x, because a positive divided by a negative is a negative, and then +2, because -4 divided by -2 is +2. Now to graph this, let's start with the first line. I'll do it in blue. Let's get the y. Use our slope of 1/2 to get another point. So 1/2. And then graph your line. And there's your first line graph. Okay, now let's look at the second one. We have a y-intercept of +2, and then we have a rise over run of -3/2. So I'm going to go down 3 and over 2, and there we go. There's our intersection point already. Right here. And so our solution to this system of equations is +2, -1. Now, as you have time, I would do this at the end of your test. Take your 2 and your -1 and plug it back into your equations and make sure they work to check your work. Okay, so let's go to the top right corner of your paper and we'll do the next one. And this says solve by elimination. So as I look over the two equations, I can see that if I were to take this equation and multiply it by 2, I will end up with -2y in the middle, and that will enable me to eliminate the y's. So I'm just going to move this other equation over, 5x plus 2y equals 3. I'm moving it just next door, no changes. And now I'm going to multiply this equation by 2 all the way across. So I get 6x minus 2y equals -14. Now, when I combine the two equations, I combine them together, these two y's eliminate, and I'm left with 11x equals 3 minus 14 is -11. Divide by 11, and x equals -1. Now, let's take this -1 and plug it back into one of the equations. I'm going to use this first one because I like the lack of negative sign. So 5 times -1 plus 2y equals 3. So we get -5 plus 2y. Then I add the 5. Get 2y equals 8. Divide by 2. Y equals 4. So the solution to this equation is -1, 4. We always like to write our solutions as a coordinate pair, and there it is. Circle your answer. Okay, let's go to the bottom left and do that question. Okay, so it says to solve by substitution. Now, in order to solve by substitution, one of your equations either has to say x equals something or y equals something. And in this case, we're in good shape because this one already is in y equals. So since that's the case, and we know that y equals 2x plus 1, I'm going to take 2x plus 1 and plug it into the y in the other equation. So I'm going to say 3, and instead of y, I'm going to put 2x plus 1 because that's what y equals. Now I'm just putting the remainder of the equation on my paper. Plus 4x equals 20. Let's distribute, and we get 6x plus 3 plus 4x equals 23. Combine like terms over here. We have 10x plus 3 equals 23. I'm going to subtract 3. So 10x equals 20. And divide by 10, and x equals 2. Now that I know that x equals 2, take this and plug it into either of your equations to find y, and I'm going to use this first one. It looks very simple, so we have y equals 2, and instead of x, I'm going to place a 2 plus 1, and so we get y equals 4 plus 1, so y equals 5. And bada bing, bada boom, there's our solution 2, 5. Okay, let's move to the bottom right of your paper, and we'll do a system of inequalities. Now, it says, plot these points and then determine if they are solutions or not solutions. So there's a yes or a no, so you can circle the one. Tell you what, why don't you hit pause, plot your points, hit yes or no, and then come back and see if you did it right. Okay, I have that the first 3 points are no, and the last one is yes. And this is one that looked, I wasn't 100% sure, but let's look at it carefully. I erased it here. It doesn't look to me like it's on the solid line. It looks like it's above the solid line, so I don't think that's a solution, but we'll check it here in a minute. Meanwhile, I do want to mention this point. It's not a solution, even though it's on the solid line. It's also on the dotted line, and dotted lines are not solutions. So this one does not work. So the only one is this orange one, which is 2, -4. What about this one up here? It's in the shaded region, but it's only half of the system. It only works for this line right here. It doesn't work for this line down here. It has to work for both of them at the same time. Now, while we're at it, let's go ahead and determine. I want you to hit pause, and I want you to try and come up with the equations. Well, I shouldn't say equations because they don't have equal signs. Find the inequalities. I want you to write the inequalities for both of those lines. Okay? So hit pause and do that and see how you do. Okay, so I have mine labeled. I did this solid line is line number 1, and the dotted line is line number 2. So there's 3 things you have to look for. First is the slope. So on this solid line, we have a slope of -4/3. There's my slope. The y-intercept is 4, and then we can see that this line is shaded below the line, so it's less than, and it's a solid line, so less than or equal to. The other one has a y-intercept of -2. It has a slope of 2/3 positive, and it has a dotted line and is shaded again below the line, so it's shaded below, is a less than sign. Now, we could double check this point here that we were a little bit unsure about by plugging it into both equations and seeing if it works. So we were right. It was a no because it does not work. I put 4 in for x, and I solved this out. I got -16/3 plus 4. So that's -5 1/3 plus 4, which means -1 1/3. And then I put the y in over on the other side, and -1 needs to be less than or equal to -1 1/3, and that's not true. -1 is greater than -1 1/3. So we were right in saying that was a no. Okay, all the other ones were very clear. Now, let's go on to the back for the 4 parts in the back. Okay, so this one says an isosceles triangle has legs that are 2x inches. The base is 8 inches less than twice one of the legs. The perimeter is 32. Find the length of all 3 sides. So, excuse me. Let's see what we can figure out here. The picture kind of has it drawn for us. And let's start with the perimeter. We can do an equation related to the perimeter. That should be easy. The perimeter means adding up all the sides. So 2x plus 2x plus y needs to equal 32. Now the second equation needs to deal with the relationship between the sides. And it says the base is 8 inches less than twice one of the legs. So I'm going to take one of the legs. Well, let's start with this. The base is, when you see that, the base is, that means the base equals. So y equals 8 inches less than. Anytime you see a less than, you need to put it after whatever it is less than. So it's less than twice one of the legs. So one of the legs is 2x. So twice that would be 2 times 2x. And then we have to do minus 8. That's 8 less than twice one of the legs. So y is equal to 4x minus 8. Now, we need to solve this. So let's see the other, let's go back up here to the first equation. We have 4x plus y equals 32. So I am going to take this equation and I'm going to subtract 4x. So I get y equals negative 4x plus 32. Now that I have this and this, you could put this in your calculator and do second trace 5, enter, graph it, and find your intersection. But I'm just going to set them equal to each other because they both say y equals, so I'm going to take this and substitute it for y in the other equation. So here's what I'm going to do. Negative 4x plus 32 is equal to 4x minus 8. So I'm going to add 4x here. So I get 32 equals 8x minus 8. Now I'm going to add 8. And so I get 8x equals 40. Divide by 8. And x equals 5. So x equals 5, which means 2 times 5, the length of this leg is 10. 2 times 5, the length of this other leg is 10, which makes sense because it's isosceles. 2 legs are the same. Now, we take the 5 and we plug it back into one of the other equations. I'm just going to use this one. And so we'll say y is equal to 4 times 5 minus 8. So 20 minus 8 is 12. So y is equal to 12. And let's see if that works out. The perimeter should be 32. 10 plus 10 is 20, plus 12 is 32, so it works. Okay, so I hope you like how I solved that. There's a variety of methods, but that's how I chose to do it. Okay, go to the top right. This is on the back side of your paper.